Today we're going to look at logarithmic functions. That's section 4 of chapter 11. Page 720, you see a list of properties of logarithms. I've also recreated it here on the screen for you. Please make sure that you've looked at and studied these properties, because you need to know these properties in order to solve logarithms. So as we begin, there's several sections to 11-4. The first one is to be able to write in exponential form a logarithm. And so let's work a couple of these out. The biggest thing about doing these problems is just putting the information in the right place. So once you can do that, you should be able to handle these problems with no issues at all. So the first one, log base 125 of 25 equals 2/3. To solve and write in exponential form, we need to take 125, which is our base, and put it over here with the 2/3, 2/3 being our exponent. So to rewrite this, 25 is equal to 125 to the 2/3. And if you put 125 to the 2/3 in your calculator, you should come up with 25. Same for the second one, log base 8 of 2 equals 1/3. Move the base 8 over to the right, so the answer would be 2 equals 8 to the 1/3. So the cube root of 8 is in fact 2. Second part of 11-4 is doing the reverse and writing in logarithmic form. 4 to the 3rd equals 64, so how do we write that as a log? Remember, the number that is raised to the exponent, the base, that will be with the logarithm. So log base 4 of what number? 64 equals the exponent. Log base 4 of 64 equals the exponent. Same for the bottom one, even though we have a negative exponent. Log base 3 being the base, of 1 over 27, that's the number on the right, equals the exponent, -3. Continuing on, we need to evaluate log base 7 of 1 over 49. In order to do that, we need to set this equal to x and then solve the problem. So we will set log base 7 of 1 over 49 equal to x. Because remember, what we're trying to find in evaluating this, we're trying to find the exponent. In other words, we're trying to find out what exponent goes with the number 7 to make the answer equivalent to 1 over 49. So that's what we're trying to solve for. We don't know the exponent. So by definition, when we solve this problem, the log base 7, the 7 goes with the exponent on the left side, the x. So 7 to the x equals 1 over 49, just like we wrote on the right side. And now we need to write 1 over 49 as a base 7 number. So in order to do that, first we need to remove it from the denominator. So 1 over 49 equals 49 to the -1. And we know 49 is 7 squared, so that will be 7 squared. Still have to keep your -1. Continuing to evaluate, multiply the exponents since we have a power to a power, so that would be 7 to the -2. Now that we have like bases, we see that x on the left is equal to the number 2 on the right. They match up, so that is in fact the answer. So x equals -2. And last but not least, we have a problem we have to solve. We have logarithms. All these logarithms have the same base 5 number. And anytime you're working a problem like this where you have a plus or a minus in between logs, remember the plus indicates a multiplication scenario and a minus indicates a quotient scenario. So in this case, in order to solve this problem, we have to multiply the log base 5 of x plus 4 and the log base 5 of 8. So what we're going to have is log base 5 of 8 times x plus 4 equal to log base 5 of 64. So now we can eliminate the logs and just evaluate the expression 8x plus 4 equal to 64. Simplifying this, 8x plus 32 is equal to 64. Subtract 32 from both sides. 8x equals 32. Dividing by 8 on both sides, x equals 4. So there you have 11-4. Please make sure and use this as a resource to study by, and best of luck.